We're going to look at the difference between the output of a VPI SDS turntable power supply and that of a Phoenix Engineering Falcon turntable power supply. I have the output of both devices connected to a scope so we can see visually what is happening. I also have both outputs connected to an audio amp, which will allow us to hear the difference between the two. The SDS uses a circuit known as a phase-locked loop, or PLL, to generate its output signal. All PLL circuits require a certain amount of time to lock when changing frequencies. When the circuit moves from one frequency to another, instability arises and can be seen in the output waveform. This is the output of the SDS when started in 45 RPM mode. The signal will start at 60 Hz and ramp up to 81 Hz. It's not difficult to see or to hear the instability in the drive signal to the turntable motor. The speed of the motor will wobble just as the waveform does. In contrast, the Falcon uses a circuit known as direct digital synthesis, or DDS, and does not suffer from the instability seen in PLL circuits. This is the Falcon output when started in 45 RPM mode. The signal will start at 50 Hz and ramp up to 81 Hz. Notice the waveform changes smoothly between the lower and upper frequency. There is no instability, therefore the motor speed is much smoother. The instability in the SDS output is particularly bad when changed between 33 and 45 RPM or when starting the unit in 45 RPM mode. While the signal appears to be steady once on speed, due to the nature of PLL circuits it is still wobbling, although at a much lower level. This instability will be reflected in the motor speed, which is controlled by the frequency of the drive signal.